All right, I'm going to talk a little bit about frame of reference and relative velocity. Um, Frame of reference, you've probably heard of this before. Essentially, all we need to think about when we think about a frame of reference is somebody's point of view. And really, we'll start diving more into exactly what I mean by somebody's point of view, but it's really about how certain people can see different things depending on what they're doing. A lot of times I like to think about on a bus, and if you are on the bus, you can sit and toss a ball up and down, and it just looks to you like it goes up and comes straight back down. But if you were somebody who was standing on the side of the road and you watched a person tossing a ball in a bus, it doesn't look like it goes straight up and straight back down. It looks like it's moving in a parabola because it moves both horizontally and vertically. So that's essentially what frame of reference is. Okay. Now, a relative velocity is essentially how fast or slow an object appears to be moving in that frame of reference. So I'm going to write down the definition here. How fast or slow an object appears to be moving relative to a frame of reference. And again, as we do a few more examples, it hopefully will make a little more sense. So one of the first examples I'm going to do is a one-dimensional or straight line motion example. So example here in one dimension. Okay. My example is going to be two objects that are moving or approaching each other. So you can think of this as two people running at each other, two vehicles approaching each other, whatever you want to think about, two birds flying at each other. So we'll make it a fairly high velocity here, some easy numbers to work with. Let's call it, the objects are going to be moving at each other at 100 miles an hour. So simple vector diagram here would have one object traveling this direction at 100 and the other object traveling at that. Okay, and if this is object A and object B, this one would be a positive 100 moving to the right or in a positive direction. This would be a negative 100. Okay, now if we took the point of view of object A, let's say this is a spaceship and you're out in space. To letter A, and from A's point of view, they would have a velocity of 0. Okay, I don't know if I really like that notation. To A, velocity of A would be 0. Well, then what they would see would be that B would be moving at them with not a velocity of negative 100. They would see them moving at a velocity of negative 200. Okay, because as long as A is feeling like it's at rest, and out in space you would feel fairly motionless, then B would be approaching you at essentially the sum of your two velocities, but it's approaching you coming in a negative direction. Now, in B's point of view, if they were 0, then they would see A approaching them at 200. Okay, so far, all we've really done with objects along a straight line has been either add or subtract them. In this case, they're adding them. Okay. So let's try another example. Let's say there's two objects moving together on the interstate. We'll say object passing another. Okay, so I get to show off my wonderful drawing skills. Okay, we'll have this be the road. Let's say we have one car that is moving at a velocity of 65 miles an hour. And then we've got another car, car A here. We'll have this moving at 80 miles an hour. Okay, so to object A, from object A's point of view, vehicle B, the velocity of B, would be traveling backwards at 15 miles an hour. And you've experienced this if you've ever passed a vehicle. It looks like the vehicle is moving away from you behind you. Okay? Or if you've ever been passed, they would see vehicle B here would see vehicle A traveling in front of them at 15 miles an hour. Okay? So this is just simple one-dimensional relative velocities. Okay? Now obviously this starts to get more tricky. All right, so let's try something in 2 dimensions. Okay? Now, before I do any examples in 2 dimensions, I want you to be aware that it's oftentimes very important to follow a couple directions here. So I'm going to say here for 2-dimensional motion, it's really important that you draw good diagrams. It is absolutely essential that you are good at drawing the situation that you read about in any question. The next thing is you want to be very careful with your labeling. Okay? And we're going to use the to subscript method. Okay? The first subscript always refers to the object itself. So if it's a man jogging, then in the first subscript might be an M for the velocity of the man. Okay. The second is always going to refer to the frame of reference, and I'm going to use FOR for that, in which it has that particular velocity. So, as an example, okay, we're going to talk about a boat crossing a river. So here's my river. Okay. Let's say that the boat can travel at 10 meters per second in still water. So if I was going to aim the boat across the river, we could say that the velocity of the boat relative to the water, so I've used a VBW, okay? We could say that that was 10 meters per second. Okay, I'm just giving it an arbitrary number here. But let's say that the river has a current, okay? And the current is downstream like that, okay? Then I can say that this is the velocity of the water, but how do you usually measure velocity of water? It's usually measured in reference to the shore. So this is the velocity of the water with reference to the shore. From the shore's frame of reference, that's how fast the water is going. And let's say that that was a 5 meter per second velocity. Now, if you aim straight across, but the river pushes you downstream, then you actually end up having a velocity that looks like that. And that velocity would be the velocity of the boat from the point of view of the shore, or VBS, and you can insert joke here. Okay. Now, let's say that the same exact boat wanted to go directly across stream. In order to get directly across stream, straight across from this point to this point, I would have to aim over this way. Now that changes the problem, because now when I aim this direction, the velocity of the boat with relationship to the water is now the hypotenuse of this triangle. And if you didn't recognize that, I made a little right triangle there. So all the vector stuff we've been talking about and breaking something into x and y components to give us another vector, that should start becoming a little bit evident at this point. Okay, and then the current would take us downstream this way, so this would be the velocity of the water with relationship to the shore, which was 5. And now, here is your velocity with the boat relative to the shore. Okay, so you see how it changes based on what the goal is. If we're just aiming across, then we get pushed downstream. If we want to get straight across, we got to aim downstream, right? Or I'm sorry, upstream. Okay. All right. I think that pretty much covers the pictures and stuff. I'll make another video here in a minute that kind of goes over a couple different examples. But that should be about it. All right. Have fun.